And we are back for part 2. So in the first digestive video, we talked about the functions of the digestive system. And then we began talking about, we talked about the layers of the GI tract wall. And then we began going through the GI tract, talking about each GI tract organ, its basic structure and function. So now that we've completed going through the digestive tract, now let's go back and talk about the accessory organs. Remember, these are what sits outside of the digestive tract, right? These sit outside the digestive tract, which means that food does not directly travel through them. They are still really important. Largely, their function for the digestive system is to produce a lot of those yummy juices that we need, the enzymes. The accessory organs are the pancreas, liver, and gallbladder. So we're going to go through each one of these and talk about their basic structure and function. Let's start with the pancreas. It sits behind the stomach. So in this picture here, the stomach would sit, I'm going to draw it then erase it, okay, so don't freak out. The stomach would kind of sit like this. It's a really bad stomach, but the stomach would sit here and it empties into the small intestine. But if we look behind the stomach, we will see the pancreas. It's oblong in shape, right? Long and narrow. The digestive function is to produce digestive enzymes. So, as I mentioned before, in the stomach, we can begin chemical digestion of starch, which means that in our saliva, we have one enzyme, amylase. In the stomach, we can begin digestion of protein. So in the stomach, we have protease enzyme, but that's it. Where do all the other enzymes come from to complete chemical digestion of carbs and protein and to do chemical digestion of fat? So many of our digestive enzymes come from the pancreas. I also want to point out the pancreas, do I see it on the next slide? Yes. The pancreas is also a gland, which means that it's part of the endocrine system, which we've already talked about, right? So we must remind and this should be a review, but please remind yourself, we must remind ourselves that the pancreas, it's also a part of the endocrine system. It secretes 2 hormones, insulin and glucagon. This is considered an exocrine gland because it dumps its hormones into a duct, which then make their way to the bloodstream. Both insulin and glucagon help in our body regulating blood sugar. So even though it's an endocrine system, of course, regulation of blood sugar is intimately related with our digestive system. So it's an endocrine organ, produces 2 hormones, insulin and glucagon, that play a role in blood sugar regulation. But it is also a digestive organ, produces digestive enzymes. I mean, I'm not going to ask you this number, but check it out. The pancreas produces 1 to 1.5 liters of these enzymes a day. That's a lot, folks. What I want to point out now, these organs sit outside the digestive tract, the pancreas, liver, and gallbladder. Food does not directly pass through them, right? Food came down from the stomach and the food's entering the small intestine. But how do all these enzymes get into the digestive tract, right? So the pancreas sits outside the digestive tract and it produces these enzymes that we need in our digestive tract. So these enzymes travel down a duct. The duct in the pancreas runs right down the middle, and that duct empties into the small intestine, right? So the enzymes that are produced in the pancreas travel to the beginning of the small intestine called the duodenum. So even though the pancreas sits outside the digestive tract, we have to have a way to get the enzymes it produces into the digestive tract. And that happens via a duct that empties into the duodenum. And folks, this is why the small intestine can do chemical digestion of all the nutrients, because now we have the enzymes for all of the nutrients in the small intestine. Very cool. I mentioned that the pancreas is also an endocrine gland, so you're going to review that. Let's talk about the liver. It is in the upper left quadrant. We should know that from chapter 1. It has 4 lobes. The gallbladder is affixed on its posterior surface like a little golf ball. And here it is peeking from the anterior view. This is what the liver looks like microscopically. You don't have to know this, but the liver is extremely, and I mean extremely, vascular, which means there's a lot of blood flow in it. So I just like this picture because it shows you all the vascularity. So the liver, it has these lobules. So I'm going to draw, it has these hexagon shape lobules. So there's a lobule, right? 1, 2, 3. I got like a stop sign, kind of a little more oblong. But that's the functional unit. So you'll see one lobule next to another, next to another. And each lobule has all these blood vessels. There's a central vein, and then all these blood vessels that lead out to these blood vessels in each corner. There's a ton of blood vessels. And the reason why is because one of the functions of the liver is to filter the blood, which we're going to talk about in a moment. But if we're going to ask the liver to filter the blood, to filter out for toxins such as alcohol, drug metabolites, if we're going to ask the liver to filter the blood, we got to have a lot of vascularity. So the blood can flow through each of these lobules and the very strung out blood supply, so we can very quickly and very well filter all that blood. Okay, I have broken down the liver into 3 functions. Okay, let's number these. 1, 2, and then we're going to take 3, filter the blood. Let's start here. One function of the liver is that it filters the blood, right? We send all of our nutrient-rich blood to the liver right after absorption. Let me say that again because that's important. Actually, I'll write it down. After absorption in small intestine, because we know our nutrients are absorbed in the small intestine. Now, as an aside, alcohol is absorbed, some parts of it in the stomach, but 80% of alcohol is absorbed in the small intestine. After absorption in the small intestine, that nutrient-rich blood, because now we just dumped a whole bunch of nutrients into the blood, travels to the liver. Exclamation point, exclamation point. That nutrient-rich blood, always, 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 the first place it goes from the small intestine is the liver. And it's perfect because one thing that the liver can do with all that blood that comes in there is filter it. We want to filter out particular toxins, certain bacteria, things like alcohol, drug metabolites. You know, we're going to see later with the urinary system. Well, the kidneys also filter the blood. They just tend to filter out different things. I mean, the spleen, we talked about in the lymphatic system, how the spleen can filter the blood. So our body has multiple filtration sites, and that's good. That means that our blood is filtered over and over and over again, and each filtration site tends to specialize in terms of what it's filtering out. The liver is filtering out more of things like alcohol, drug metabolites. The kidneys are filtering out things more like protein breakdown products called urea, muscle breakdown products called creatinine. It's filtering out excess glucose, the kidneys, excess sodium, things like that. So the blood is filtered again and again, and here we see one example of that in the liver, and it does more filtering out things like alcohol and drug metabolites. Another function of the liver is to produce bile. Bile is a particular substance that is needed to break down fats. Make sure you can put those two together. So, another function of the liver is to produce bile, and bile is a specific substance that's needed to break down fat. Lastly, decides what nutrients to store, what nutrients to keep in the blood. I know that's a mouthful. My goal was to try and make it easier. So as I already wrote on the next slide, all the nutrients absorbed from the small intestine, all that nutrient-rich blood, goes to the liver. In addition to the liver filtering the blood, something else that it does, it decides which nutrients to store and which to keep in the bloodstream. I've got an example here. You know, if you eat a big meal, there's going to be a lot of carbohydrates in that meal probably, or some. Well, it's likely that you don't need all those carbohydrates to stay in your blood right away. You know, if I have a bowl of rice and veggies, well, the rice has a lot of carbohydrates. I digest them, I absorb them, but I don't need all that blood sugar in my blood right away. So your liver will keep some sugar in the blood, because we have a nice normal range for blood sugar. So your liver will say, okay, we're going to keep this amount of sugar in the blood, but then we're going to store this amount of sugar for later. And that's a good thing, because later, if you haven't eaten for a couple hours, no big deal. If you haven't eaten for a couple hours and your blood sugar starts to go down, well, your liver just releases some of its sugar stores. Perfect. All right, good stuff. Now, the gallbladder sits underneath the liver, and its job is to store bile. So the liver produces the bile, and then that bile travels to the gallbladder where it's stored. People usually ask, well, what happens if you take the gallbladder out? Because someone can certainly live without a gallbladder. Well, sure, if the gallbladder is creating more problems than it's being helpful, you take the sucker out. And what happens is the liver just takes over, storing more of that bile. Will that person have to be careful more about how much fat they eat at one sitting and or overall? Yes. But the body will compensate rather well. I've already mentioned some of these ducts. You don't have to know the specific name, so I'm not going to ask you cystic duct, hepatic duct, bile duct, main pancreatic duct, accessory pancreatic duct. All I want to make the point is, though, the bile comes from the liver and the gallbladder, and then we have enzymes coming from the pancreas. They're all going to travel and dump into the GI tract at the duodenum. Bile comes down here, bile comes down here, empties into the duodenum. We already talked about the enzymes coming from the pancreas, empty into the duodenum. This is how all these secretions get into the digestive tract. Very cool. All right, we're going to end here by just talking about a couple specifics. This is, of course, a much more detailed topic. I just want to point out a couple, and I really mean very few, a couple things that are unique about carbohydrates, fats, and proteins in terms of how they are digested and absorbed. Okay, so here we go. I've even put in red what I'd like you to know. Try and be as clear as I can. Carbohydrates tend to be the simplest in their structure, and therefore are absorbed the fastest. I don't have that in red for some reason. I made a mistake, but I'm telling you now, I'd like you to know it. Carbohydrates are absorbed the fastest. So if we need quick absorption and energy, you want carbohydrates. We already know that we can begin some chemical digestion in the mouth, starch only. And even though they're the fastest to be absorbed, they do not provide the most energy. You don't have to know these numbers, but just to give it some numbers for help of understanding. For every 1 gram of carbohydrate that we digest, absorb, and metabolize for energy, we get 4 kilocalories of energy. What we're going to find is fat. 1 gram of fat will yield 9 kilocalories. So we had 4 for carbs and 9 for fat. So fat actually gives us double the energy, but of course, fat takes longer to get to. So we kind of get the best of both worlds. In the meantime, while we're waiting for fat to go through all of its steps, we can absorb and metabolize carbs quickly, and then fats we can get to later, so it takes longer to absorb and metabolize the fats. But once we do get to them, they provide us with more energy. Here we go. Fats take longer. There's more steps, they're more complicated. We need bile. Bile was something that was specific for fat. However, even though it takes longer to get to, once we successfully digest, absorb, and metabolize lipids, it gives us more energy. Good. What about protein? Protein also take longer to digest and absorb than carbs. So basically, carbs are our quickest energy source. The process of absorbing and metabolizing proteins and fats takes longer. Proteins are also pretty complex. Remember, we don't use protein for much energy. I would say maybe 10 to 15% of all of our cells' energy needs come from protein, which means that our cells get most of their energy. Our cells get 85 to 90% of their energy from carbs and fat. But instead, these are the functions of protein. So we don't metabolize them for energy, but we use them to give structure and to help form chemicals. You should be reviewing what I'm reviewing. Nice and quick, like I said it was. Quick second video, but we still have metabolism coming up, so stick around for more.